Ho ho ho! I've got a fantastic new game for you guys just in time for the holiday season. It's called Santa Claus Lane, and we've got a full tutorial to show you how to make it yourself. You play Santa Claus, dropping presents to all the good little boys and girls in the world. But watch out because the skies are more crowded than ever.
Mayday, mayday. Going down.
Build up score streaks and try to add time to your timer in a tense race against the clock. So what are you waiting for? Hitch up the reindeer and let's get coding! So to save you the trouble of having to track down all the resources we're going to need to make a big complicated game like this, we've got all the graphics and sound effects and the variables and things that you're going to need to build this all saved in one file. We call it a starter file. It's basically a blank version of the file where all you have to do is add the code. So that way you'll be able to follow along with us. You can find the address for that right up above here, or you can go down below to the links in the description and get to the starter file that way. So if you're going to follow along with me, just load that file up. Watch a little bit of this video, pause, do some coding, play a little bit more of the video and pause and do some coding. And that way you can get through the whole project with me and hopefully learn something along the way. So our starter file has all kinds of graphics here. We've got this lovely Santa Claus that I imported into Scratch. It was an animated GIF file. And as some of you are probably aware, bringing an animated GIF into Scratch through the import function will turn into a whole bunch of costumes so that you can replay that animation. So this is going to be our main character in the game. He's going to be flying back and forth, and we'll get to moving him around in a little bit. We've got some buildings here as well. They're just random urban type dwellings that I've downloaded off the internet. There's 10 of them to choose from. And we have some other stuff here, some clouds that we're going to use to dress up the playing area a little bit, and some hills here in the foreground. And this is the first thing that we're going to get scrolling across the map. So because this is a scrolling game, we're going to have the background and the houses scrolling across the screen here as we're moving forward, and constantly kind of moving on to the next screen as we try to deposit toys into houses. So to get the scrolling working, we're going to first need to create a variable called scrollX, and that's just going to be tracking how fast this graphic and the other graphics that are scrolling across the screen are going to be moving. So we're going to set our scrollX to -1. And that means that we're going to start at the beginning of the game moving this background across the screen at a speed of -1 every turn, basically. We're going to go do that in the backdrop. So let's go over to the backdrop and we'll have a look at the code tab here. When the green flag is clicked, we're going to set that variable scrollX. It's a global variable. We're going to set it to -1. And so all the sprites that are scrolling are going to refer to that variable. The trick in this game, though, is we're going to make the game go a little bit faster all the time as we're playing. So as soon as we set that initial variable, we're going to set a forever loop here. And inside here, we're going to change that scrollX by -0.05. And we're going to do that every second. So as you can see when we start the game here, nothing's going to actually happen. But if you look at this variable, so the scrollX is slowly speeding up as the game progresses here. So in a set now we're moving at -1.5 pixels per turn here. Eventually it'll get up to 2, 3, 4, and it'll get going quite quickly. So the game is going to intentionally get more difficult as time goes on, and we're hoping that will add some challenge to the game. All right, we're going to revisit this backdrop in a little bit, but let's go over to the snowy hills. That's the first thing we're going to get scrolling across the screen here. I've already got some code laid out here to give us a start. So we're going to start again with a green flag. And the background is always at the very back, but right behind that is going to be our hills. So all our houses are going to be in front of the hills, and anything else that appears on the screen is going to become in front of the hills. So we're going to grab a look block called go to back layer, and that will move this hill block right to the very back. We're going to start it right at the middle of the screen. So we're going to make our X 0, and our y minus 122, which will fit it right along the bottom of the screen here. You can see how nicely and snugly it fits in there once we get that coordinate locked in. All right, so now our mission is going to be to start scrolling it across the screen. Of course, there's limits to how far we can scroll this thing. Scratch will only let you drag it so far before it starts to protest. And it's usually with something like this, that's the entire screen width. We're actually going to get to an x of minus 465 before the object will just refuse to budge anymore. So we're going to, when that happens, we're basically going to have another block following behind it. So we're going to make a copy of this. We're always going to have two of these guys on the screen, the first guy and then another guy trailing behind him. These guys are fairly seamless. They're made so that they can fit together quite nicely. So a second guy who will be a clone will be following behind the first guy, and he'll be taking his place. And then when this guy gets to the end, he'll be cycling back to the beginning. Let's go ahead and code that. So we got this guy in his starting position. So we're going to forever be changing our x by scroll x. We could just go change by 1 to scroll across, but that would be a constant speed, right? So we want to change it by scroll x so that it is accelerating as we're going along here. If you're looking for this little scroll x variable, by the way, all these little bubbles that have the names of the variables are underneath variable here. Every time you create a variable, you'll find a little bubble for it, and you can put that any place that's round here in the interface. So we're going to change x. Instead of changing it by -1, we're going to change it by scroll x, which is going to be -1 basically at the beginning. Okay, so we need an if statement down below here that says if this guy gets as far as he can possibly go, which is minus 465, we're going to call it, because we're not going to necessarily exactly land on 465 because we're going down by fractions, we've got to basically use a comparison here. We're going to say if it's less than minus 464, it might be minus 465, or it might be minus 465.1 or 0.2 or 466. So as long as it gets below that figure of minus 464, we'll know it's time to recycle this guy and bring him back to the other side. So we're going to send them all the way over to 465, positive 465, which is all the way over as far as it'll go on the right-hand side of the screen. And so let's just watch that in action. So our guy is scrolling across the screen, and then we're just going to want to recycle it and bring it back to the other side. There we go. Beautiful. So all we have to do now is create a second version of this guy. Let's go ahead to our control blocks and grab a create clone of myself. And we'll do that just before we get into the forever loop here. Now we have to order the clone around, and we're going to tell the clone to go to a different starting position behind the other one, of course. So we're going to want that to go to 465. So let's go grab another go-to block. We'll tell it to go to an x of 465. And we'll keep the y position the same. And the rest of it just can duplicate. So I'm going to move my mouse cursor over this forever. I'm going to duplicate this entire forever. So both these blocks are going to be moving the same way, just they're going to be offset from each other a little bit. All right, let's have a look at what that looks like on the screen here. Beautiful. Now there's a little bit of an imperfection here that you can see, and that's because Scratch isn't actually able to move stuff entirely off the screen, and the math is a little bit complicated. But unless you do some very complex trickery in here, we're never going to get a perfect seamless match between these two tiles. We could get it done if we were using tiles that were, if we were using 3 tiles instead of 2, for example. But I'm just trying to keep this simple. So we'll make do with what's there. It's looking pretty good, and with the buildings and stuff in there, no one's really going to notice. Okay, we're going to turn our attention to the buildings now. We're going to start them scrolling across the screen from the right to the left, and they're going to match up with the speed of the hills, so it'll look like we're passing by houses as we scroll across the screen here trying to deliver our presents. So we're going to start our guys right off the far right-hand side of the screen at a y of minus 180 and an x of 240. And let's make that first guy visible here. So that'll take him right off the edge of the screen here. We're going to have them hidden at the start. And so this is going to be the reference object that's going to be making copies of itself. So we never need to have this guy be visible. We're going to have its clones be visible. So we're going to create a forever loop here for creating our clones. We're just going to keep constantly creating new copies of our buildings for the entirety of the game. Now we're going to use a variable called building on screen. Now we ran into some trouble as we were developing this game with the idea that as the screen started rolling faster and faster, the houses would get closer and closer together. If we did a timing, if we did wait 1 second and create a new house, then our houses would end up being far too close together. So we did an interesting thing with the coding here was we're going to wait until this first house has reached a certain part on the screen before the next house is able to spawn. We're going to do that with a variable called building on screen, and that is a global variable. Yeah, it's a global variable, so that just applies to all sprites. So we're going to set that variable to 0. So we're going to set that variable to 0, and then we're just going to put this clone creating process in a holding pattern here. We're going to use a wait until block, which is a control block, and that's going to freeze the script until that variable building on screen becomes 1. So once this first building reaches the right point on the screen, it'll give permission to make the next copy of itself, basically. So let's go wait until building on screen. All right, so that's all the instructions for the main object that's creating the clones. Now let's go over to when I started the clone. We're going to do an infinite loop here forever. And inside there, the first thing we're going to want to do is check and see whether that first building has reached the appropriate point on the screen so the distance is good. So we're going to use an if statement here. If our x position, remember we can find the x position under motion here at the very bottom left of the screen. There's a couple of bubbles for x and y location. So if our x position is less than 50, and 50 is, let me show you where 50 is. So once our building gets to here, to this spot, then we'll have permission to make the next guy, and that's basically going to be the space between our houses here. So if our x position is less than 50, then we're going to change that building on screen. We're going to set it to 1, which is going to trigger the creation of another clone over here. After we're done that, we can stop this script. So this script is going to do nothing but control the... So this script is going to do nothing but control the building making process. These two working in tandem together are going to keep our buildings being created. All right, we can't really show you anything yet because we're just going to be creating a whole bunch of houses over on the right-hand side of the screen here, and that's not very interesting. And they're also invisible, which doesn't help as well. So we're going to do another when I started the clone here that's going to actually control how the buildings move across the screen here. So when our building is created, when it starts as a clone, you can find that when I start as a clone at the bottom of our control blocks here, by the way. So when it starts as a clone, we're going to want this first guy to show, but we don't actually want to see him yet. We're going to make him invisible using a ghost effect. So we're going to have him fade in on the screen as he scroll comes across here. And then at the end, we're going to have him fade out. And that just looks a little bit more pro gamer to rather than having it come in off the edge of the screen. It's never going to be able to completely get off the screen because of the way that Scratch is set up. So to avoid that discomfort of having the thing suddenly appear at the side of the screen, we're going to have it slowly kind of appear on the screen here. Let's set the ghost effect to 100 then to make it invisible. Our default size of 100 is a little bit too big for these buildings. So we're going to shrink them down to 60%, which is a little bit more manageable. We're going to make sure they're in the front so that they're in front of our snow hills, of course. And we're going to want to pick one of the 10 costumes for our guys. We're just going to use a random number pick here. So our houses are between 1 and 10 here. And we're just going to basically switch costume to a random number from 1 to 10. And every time this is invoked here, let me just stop this to make this house visible. Every time this is selected here, you can see that it's going to just pick another random house. So that no matter, every time we play, our village is going to look a little bit different here. All right, so we're going to pick a random house. Then we're going to have our house fade in. So we're going to use this change ghost effect by -5. And we're going to do it 20 times. So 20 times -5 is -100. I'm sorry, there's math involved. Yes, there is. So that is going to make our house fade in. So let's go ahead and set that ghost to 100. You can see what that looks like. It just suddenly fades in like that. Beautiful. All right, while it's fading in though, we already want it to get moving. We don't want it to stand still until it fades in. So we're going to, for the duration of that, we're going to change our X by scroll X, which is the same formula we were using to move our snowy hills around as well. So that will make this house start to move across the screen. And if we test the program out now, you'll see that we have our houses being generated quite nicely. We've got our first house. And if we test this out now, we can see that our house does in fact fade in and start moving across the screen. It stops right away though, because it's only moved 20 pixels here, and then we've run out of code, and the code is ended here. So we need to keep it moving. I just wanted this 20 loop here to give this guy enough time to fade in. After that, we can continue to move with this change X by scroll X, but we're going to do it until the guy gets to the other side of the screen. So we're going to repeat this change X by scroll X until the X position is less than -240, which is the left edge of the screen. So as soon as we get across the left edge of the screen, then we can fade out again. So we're going to use a repeat 20 times, the same as we did here, except we're going to change the ghost effect by a positive number, which will make it invisible again. All right, and then once we're done with that, we can delete the clone. It's going to be invisible anyway, and we'll just get it off the screen so it's not bothering us anymore. Okay, I think we can test this out properly now. So there's our house appearing. It starts moving across, matching the speed of the hills here. And as soon as it gets to this point here, the next house is created. Oh, coincidentally, we have the same kind of house here. Now we've got a different one. And you can see that once the house gets to the edge here, it starts to fade out. It seems to kind of stop before it fades out, which is a little frustrating. I might change this to -230 and then have it fade out. I think that might look a little more natural. Let's have a look at that instead. These kinds of little tweaks are things that you can modify in your own game as much as you like. You can change the scroll speed, change the space between the houses, all kinds of things like that. All right, that's looking a little bit better. All right, perfect. Okay, so we'll deal with our houses later. We're going to be adding some extra code to make them detect whether they've been hit by a falling present from Santa Claus. But for now, this will do. So let's go ahead and start coding Santa now. That sounds exciting. Okay, so we're inside our Santa sprite now. And let's switch the costume over to the first Santa here, just so we can see what we're talking about. We'll make him visible and just drag him onto the screen here. There's lovely Santa Claus, looking quite nice. We're going to get a green flag to get him started off, and we're going to do a forever here. And firstly, we're going to attend to the controls here. So we're going to use arrow keys here. You can use WASD if you'd like, or you can use both if you'd like as well. You're free to set this program up however you like. But I'm going to use arrow keys. So this is a little bit complicated. Let's break it into little pieces here. So we're going to use a variable called x speed, another one called y speed to control the movement here. That's because we want to have some acceleration going here. When I hit the arrow key, I want it to start off slow and then build up a bit of a head of steam. And I want the same thing to happen when I'm slowing down. I want to have some momentum so that when I push the keyboard in the opposite direction, it doesn't immediately turn around. I want it to slow down and then slowly start moving backwards and then more quickly move backwards. That's going to make our sleigh a little bit more sluggish, which is a little more realistic considering that we're flying in the air and you can't just stop on a dime. So we're going to do that with this variable called x speed. There's another variable called y speed. This is a global variable, but it doesn't really matter. We're just using it for Santa Claus right now. So we're going to say if. Now we want the left key to be pressed here. We've got a couple of other circumstances that we're checking for, and I'm going to explain these right now. So we need 3 different things that we're checking here before we're allowed to move left. So I'm going to grab an AND statement and put it inside another AND statement. And so we've got 3 different things we can check for here. So if I'm pressing the left arrow key, and there's a variable here called frozen we're going to be using in a second, and if it's set to 0, then we're allowed to move left. What's going to happen is if we end up crashing into an airplane or a flock of geese or something while we're in the air, we're going to be temporarily unable to control our vehicle. So if frozen is equal to 1, our Santa's not going to respond to keyboard inputs, and he's just going to kind of flail around in the air out of control for a little bit. This x speed is greater than -7. Well, that is our speed limit. So if I try to accelerate beyond -7, it's going to ignore that number basically, and the left arrow key isn't going to work anymore. So the actual movement's going to be changing the x speed by -1, which will get us moving in the leftward direction. Our x is going to start getting less, and we're going to start moving across the left side of the screen. So every time while we're holding that key down, that x speed is going to increase. The first time it goes around this loop, if we're holding this button down, it's going to be -1, then -2, then -3, and it'll very quickly get up to -7, and then it'll get stuck. It won't be able to go any further. So movement in the other direction is more or less the same. If you're coding this at home, you can just duplicate this if statement and add it below and just make some minor changes to it. I've already pre-baked it here for you though, so let's just have a look at what's here on the screen, and you can just freeze frame here and make sure that you've got the same code that I've got here. So when we click the right arrow, none of this other information changes. We're just going to change the x speed by +1 instead of -1. When I go up, we're going to change the y speed by 1. And when I go down, we're going to change the y speed by -1. I've made one other tweak in the code here that's a little bit different. When I try to go up, the max y speed is less than 5 instead of, you can see the 7s or -7s that are here for the rest of the numbers. I just did that to kind of simulate how it's a little harder to move up against the force of gravity than to move in other directions. So I kind of made the max speed going up a little bit slower. If you don't like that, you can feel free to tweak these settings anyway. So moving to the right is going to change our x speed by -7, or sorry, moving to the left is going to change our x speed to a max of -7, +7 at the right, 5 going up, and -7 going down. All right, so if we test this right now, absolutely nothing's going to happen because these variables don't actually connect up to the XY position of Santa. In order to do that, we're actually going to have to go and change the XY coordinates to match our current x speed or our current y speed. So let's go ahead and do that. I'm going to grab a change x and a change y block, and we're going to put it inside the loop outside of the if statements here. So we're going to change our x by whatever our x speed is right now. If it's 5, we're going to move at a speed of 5, etc., as long as it's within these speed limits here. And the same for our y. All right, we can test this out. Things aren't working perfectly yet. There's still a few more things we need to play with. You can see that our craft here is working, and it does have that kind of momentum we were looking for here, but it's flying a little crazy, and it has a tendency to go right off the screen if we're not careful here. So we're going to have to do some things to constrain the movement of our Santa and make it a little more realistic. He's also just moving a little bit faster than I want him to, but we're going to take care of that in a second. So the first thing we're going to want to do here to control this guy's movement a little bit more is we're going to start bleeding off a little bit of speed. We're going to create basically some friction here so that if we're not pressing a keyboard command, we're not going to continue to accelerate. We're just going to slowly decelerate until we finally settle down to a speed of 0. So, and that's going to actually slow down our craft as well. You're going to see that once we do that, things are going to move around the screen a lot less quickly. So what I'm going to do here is I'm going to do a command that says, I'm going to do an if statement inside here below these other if statements. And let me take this apart and show you what we're doing here. I'm going to show you in a little more detail. So if we're not pressing any key, so not key any pressed. So that means if we've let go of the keyboard and we're no longer telling it to move in any direction, and if we're moving at a speed greater than 1, then we're going to start bleeding off our speed. So I've set this up in a bit of a weird way. You'll see as we play it, though, that it does feel kind of cool. It's going to be impossible for us to stay completely still on this board because you're flying through the air and winds are wafting around. So what I've done is I've set basically a system here where once you get your speed gets less than 1, then you then the speed's not going to bleed off anymore, and so it's going to be very, very difficult to hold your craft still at any time. So if we're not pressing any key and the absolute value of our speed is greater than 1. Now I said absolute value, I could have said speed is greater than 1 here, but what if our speed was a negative number? If we're moving backwards and our speed is -5, well, that's not greater than 1, which means that we're not going to bleed off speed. So by taking the absolute value, we're stripping that negative off of it, and we know if we're going at -5, we'll want to continue slowing down here. So I'm going to go the absolute value of my x speed if it's greater than 1. So if it's greater than +1 or less than -1 is what we're saying, and we could have written that way if we wanted to. So if I'm not pressing any key and our speed is too high, then I'm going to bleed off some speed. I'm going to change my x speed by x speed times -0.1. So because we put this in a multiplication sign here, what we're really doing is bleeding it off at a variable speed. The faster I'm moving, the more speed we're going to lose. If we're moving at a speed of 7, for example, we're going to lose 0.7 speed every time, every cycle of the game here. And if we're moving at a speed of 2, we're only going to drop at a speed of or at a speed of 0.2 basically. So this is going to variably change our speed so that the faster we go, the faster we slow down when we're not giving it any keyboard inputs. You're going to see in a second as we're playing this that this is going to make the game just feel much smoother and more pro as we're playing it here. So this kind of variable speed thing is a script that you can use in almost any game when you have movement. If you multiply your speed by a variable, you end up accelerating more the faster you're going, or decelerating more the faster you're going in this case. Okay, we want that change x and change y to be at the bottom of all of this, so let's just plunk those if statements down below the other ones and make sure our speed's at the bottom. And let's see how our new bleeding speed is affecting our movement now. So you can see that our character is moving on the speed around the screen. He's still moving quite nicely, but it's feeling a little more realistic now. You can see that as I move backwards, when I let go of the keyboard, he slowly bleeds off speed, but he still keeps drifting around. If I move him up and then let go, he keeps drifting up. If I move him down, he keeps drifting down. So I did a lot of playing around with these numbers, and I'm really quite happy with the way this worked out. It feels like we have control over our craft here, but not complete control, because we are flying through the air, as I said, and we are being pulled by reindeer, which does make things a little bit more complicated. Okay, that is working beautifully now. Now, the other thing we want to do here is constrain our movement. We don't want to be able to go off the edge of the screen here. That's just not playable here. And if we go too far off the top here, we actually disappear right off the screen. So we're just going to set some boundaries around the screen here. We're going to say if our coordinates are too much in any direction, we're not able to move. We're going to do that with a series of if statements again. And we're going to put those in. I'm going to explain those in just a second here, but we're going to again put our change xy at the bottom and drop this in below our other if statements. So we just have a series of if statements here. That's all we're doing. Okay, so this first if statement says if our y position is less than minus 25. So minus 25 is right here on the screen, and I've decided that is as low as we're going to be allowed to go on the screen right now. I'm going to put these in one at a time here just so we can see. So as soon as this is in here, what's going to happen is as soon as we try to get lower, it's going to automatically reset our y to minus 25. So that no matter how much we try, we're just never going to get below minus 25. And you can see that in action on the screen here. I can move in every direction, but when I try to move down, I've got this artificial limit at the bottom of where I'm allowed to go. So if you're remixing this game, you can certainly feel free to play with these variables a little bit. If you want to go a little lower down on the screen, for example, we could change this minus 25 to minus 75. Make sure you change it in both places though. And you can see that now we're able to go a little lower down on the screen, right to rooftop level basically. That's a little too low for my comfort though. I think air traffic control would have some issues with Santa being down that low. So I'm going to revert it back to minus 25. There we go. That's looking a lot better there. All right, so we're just going to do the other if statements to constrain our movement in the other directions. Make sure your greater than or less than signs are in the right place here. So if our right hand position is greater than 130, we're going to set our y to So we're going to go ahead and place these other three if statements here to constrain our movement in all the other directions. Be careful about the greater than or less than signs though. We're going to want to make sure they're facing in the right direction. And if your thing refuses to move or is moving in the wrong way, it probably has to do with these greater than or less than signs here. So if we're moving up, we're going to constrain our y position to 130, which is close to the top of the screen. To the right, we're going to make it greater than 230. And to the left, we're going to make it less than minus 230. Let's plunk all those in there above the change xy and have a look at where we're allowed to move now. There we go. So this is as far forward as we're allowed to go. This is as far up as we're allowed to go. This is as far down as we're allowed to go. And to the left, we're constrained this way. Again, if you're not happy with any of these values, you can play around with them and come up with your own set of boundaries here. Okay, let's go ahead and add some costumes here. I mentioned that Santa does have a bunch of animated costumes here. We can go ahead and do like a next costume in here. Green flag, forever, next costume. But we're going to run into some troubles because we have some costumes here that we don't want to look at. We're going to be using these a little later when we're dropping presents. So when we get to the end of our costumes, we've got 23 of them here. We're going to go, Scratch is going to bring you right back up to the top again and try to play this top costume. We're going to want to catch it in its tracks here and have it skip these first two and jump back to here again. I'll show you the code to do that. We're just going to grab an if statement here. And we're going to say if the costume number we're wearing is equal to 1. So if we come all the way around this list and we're back at the top again, it's going to immediately jump before we can even see this number 1. We're going to switch costume back to Santa again. All right, and that's going to work quite nicely. Let me show you that. It's still running a little too fast. You can see poor Dasher and Dancer's legs are moving around a little too fast here. They're going to get exhausted. So let's add a little delay there. I'm going to say 0.2 seconds. And you can tweak that if you want the animation to run faster or slower. I think this is looking pretty good now, though. All right, we're still inside the Santa Claus sprite. We're going to make Santa start to drop presents now. Just for simplicity's sake, we've actually made the presents be a version of Santa Claus, so that when the time comes for Santa to create a gift, we're just going to, instead of having to track down Santa's coordinate and have the gift jump to that spot, he'll already be there because he will be Santa. So Santa's going to make a clone of himself right on top of the spot where he is, and then we're going to start that gift dropping down through the air, basically. So when green flag clicked, before we do that, we're going to set a whole bunch of variables here. We need at some point to initialize some of the variables we're going to use in the game, and this is as good a spot as any. So we've got a score variable. We want to reset our score to 0 at the beginning. We've got something called streak score here, and I'm going to explain that in more detail later on. But basically, the more we do good things in the game, the more our score is going to increase. So when we drop a present on one house successfully, we'll get 1 point. But the second time we do it, we'll get 2 points, and the third time we do it, we'll get 3 points. And our points will keep going up the more houses we get in a row. That streak can be broken, though, if we make any kind of mistake, like we leave a house that hasn't had a present on top of it, or if we miss a house entirely, our streak is going to be broken and our streak score is going to go back to 1 again. So getting a high score in this game is going to mean very exacting movements and perfection. If you make even one mistake, you're going to go back down to 1 point again. You're going to lose a lot of opportunities to score points here. So that's going to be one of the challenges. We've got a variable here called frozen, which I already talked about, which is going to be whether we've hit something in the air or not. Once that frozen is set to 1, we're going to be temporarily unable to move. We're going to show some of these variables right now. The score is going to appear at the top of the screen. Let's take a moment to hide that scroll X so we don't need anymore. So we're going to show the score variable at the top of the screen there. And we're going to show the time remaining, which is going to go at the top left here. Those are going to be hidden at the beginning of the game when we're looking at the thumbnail. We don't want these scores and stuff to make our thumbnail look ugly, so that's why we need to show them here at the beginning of the game. At the end of the game, we're going to show a variable called final score, and we're also going to use a cloud variable here called high score that's going to actually determine the global high score for this game, and I'm eager to see how you guys do at this. So we're going to hide both those variables. They're only going to show up at the very end of the game when our end screen is running. So we're going to show these variables and hide some other ones when the game starts. Okay, so we're going to, so Santa's already at 30% of his original size here, though we've never actually set it that way. We're going to have to change the size when we make our presents. So we want to make sure that we've started off at the proper 30% here so that Santa's always the right side. Santa, we're going to give him a starting position. Let's get Santa back into his proper suit. He's looking a bit weird. So this was kind of arbitrary, but I decided that this is the spot where he's going to be. Since we're not moving at the beginning of the game, he's going to start dropping, and by the time the game starts, he'll be kind of around the middle of the screen here. I did some playing around, and that seemed like a good number. So our X of -100 and our Y of 150. All right, at the beginning of the game, we're not going to be able to see what's happening here, so we are just going to move our character. We're not going to see because we're going to have a thumbnail on the screen here. Nothing much of interest is going to happen for the first 2 or 3 seconds, but what I've done here is while the thumbnail is fading away and while you're trying to get yourself oriented here, we're just going to move our character forward. He's going to start to just scroll forward as if we caught him in the middle of moving across the screen here, and by that point we'll be able to start directing him to go in whatever direction we want to have happen. All right, so we're going to make it so that we drop a present every time we hit the space bar here. So let's grab a forever key, a forever loop here. And inside here, we're going to start detecting whether our key space is pressed. And again, we're checking here to see if our frozen is equal to 0, because if we're frozen, we're not going to be able to drop a present, of course. So otherwise, we're going to be able to drop a present every 0.2 seconds. And so when we click that space key, we're going to have a falling noise start. Just a little kind of slide whistle sound here. And we're going to, at that point, create a clone of ourselves. We're going to switch that clone over into a present, but at the moment here, we're just creating a copy of Santa here. And to make sure that we can't do it again, we're just going to wait. We're going to freeze the script here so that nothing can happen for 0.2 seconds. And that's going to stop us from spamming presents accidentally. We don't want to spam presents in this game. You can put more than one present on a house if you want to, but remember that if you miss, you're going to blow your streak score and in the end lose out on a lot of possibility for points here. So that's going to make it so that you can't accidentally drop too many. Without that, I might show you later, you'll end up just raining presents all over the screen here. Okay, so let's go ahead and start as a clone. So I've made a copy of Santa right on top of his current location. And the first thing I'm going to do is move him backward 40 steps. Why am I doing that? Because the present is always going to drop in the middle of our sprite because we've made a clone of ourselves. So it's going to turn into a present and it's going to fall right from the middle of the sleigh, which is not good. We want it to drop from Santa. So the first thing we're going to do as soon as we turn this guy into a present is we're going to make him go to the left 40 pixels, and that'll put him right underneath Santa Claus before he starts dropping. All right, we're going to switch that costume to a gift. For the clone only. We're going to make the color of our present random. So this is just a nice little touch. It's probably not even going to be visible when our presents are falling down from the sky, but I just thought it'd be a nice touch to add, and it didn't really take any effort to do. So we're going to make our color effect. So color effect is under the purple looks blocks. We're going to set it to a random number from 1 to 200, and you can see here that every time we click on this, we get a slightly different color. We've got a green present here now. It's a little hard to see on the screen there, but we've got all kinds of different colors. And that'll create the impression that there's a little bit of variety in the presents that are being dropped. We're going to set the brightness effect to 10, and that's just going to perk these guys up a little bit. I just thought they were a little hard to see as they were falling against the night sky here. So I just added a little bit of brightness to them. We don't want the Santa to look that way, but we do want the presents to be a little bit brighter. We've got a velocity variable here. This is another global variable, I believe. Let's have a look at velocity. Oh, actually, sorry, it's a local variable. So it's a variable for this sprite only. So each gift is going to have its own velocity. That's right, because we might have more than one present falling at a time. So make sure when you're making a local variable like that it says for this sprite only, and that of course will only affect that falling present. And if we make another present drop, it's going to have a different velocity all its own. We're going to set the size to 30% for the present, but we're going to start shrinking it in a minute. So the default size of 30 is good at the beginning, but as it falls down from the sky, we're going to make this guy shrink a little bit. All right, so we're inside a forever loop now. We're going to change our y by this velocity variable. You can see it starts at 0, so it's not falling at all. But we're going to change that variable and make the thing fall faster and faster and faster, the way things do accelerate as they're falling. As it's falling, we're going to change our size by minus 0.5. So as it falls, it's going to change. I'm not sure how many cycles we're going to get through of falling here, but it's probably going to change by 20 or 30% before it finally hits a house, depending, of course, on how high you are when you drop it as well. So the last thing we're going to have to do to get these presents actually dropping is we're going to have to change that velocity variable. So we're going to change it by minus 0.5 each time we go around our loop here, which means it's going to drop very slowly at first and then start to accelerate as it continues. So let's put that in there and we can actually test this out now and have a look at what that looks like. There you go. And that's looking pretty good now. So we need to have stuff happen when we drop the presents. Right now they're just kind of dropping and landing at the bottom of the screen and getting stuck there. So there's really two things that can happen when a present falls in this game. It can land in the snow, which is going to mean our present is lost and that will be a sad thing. Or it can land on a house, in which case a child will get a present and everything will be right with the world. So let's go ahead and program both those circumstances. They're both going to happen inside an if statement here. So let's go ahead and grab our first if statement here. The first if statement is if touching edge. So that's going to be basically if we keep falling here and we end up down at the bottom edge of the screen, that will mean we have missed a house, because if it touches a house before it hits the bottom of the screen, of course, it'll never get a chance to touch. So this is the first thing we're checking for, is if it's touching the edge. And then after that, we'll check for touching houses. So we're going to drop that if statement inside the forever loop here. So if we're touching the edge, we have done a bad thing. We're going to punish ourselves by changing the score by -1. We're also going to get rid of our streak score. So if we've been streaking and getting multiple points for the same house, we're going to punish us for missing by setting our streak score back down to 0 again. We have a lovely sound here called splat that is going to show that we have missed our house. We're going to clear graphic effects here, which is going to get rid of that weird color effect that we added to our presents. We're going to switch our costume to something called Gifts in the Snow, and that costume is this one here. So it's just a little graphic here that's telling us that we've lost 1 point, and we just got some presents sitting here in a snowbank to show us that we have wasted a present. A little bit of visual feedback to make the game a little more fun and show you how badly you have failed. So we're going to switch that costume. We're going to reset the size to 30% again, because we've been shrinking as we've been falling and we want to get back to that default size again. Now I'm changing Y by 30 here, which is going to move the graphic up. And the reason for that is because this graphic here, we don't want it down at the edge of the screen. We want it up here so that it's a little bit more visible. So we're just so when the present lands, it's going to immediately pop a little bit off the ground so that this graphic can be fully visible against the ground here, basically. And then we're just gonna make sure that the present that's been dropped in the snow here stays on the screen a little bit. So it's gonna have to follow the scroll X across the screen. It's gonna have to actually move along with the rest of the stuff. Otherwise, it's gonna appear to be moving forward through the snow. If we want it fixed on the ground, we're gonna have to keep changing it by this scroll X. So we're going to do it 30 times here. We just want it on the screen long enough for you to be able to see and register that you missed here in case you didn't get the clue. So we're just going to leave it for 30 times, which is going to be about 1 second that we're going to be able to see that on the screen. And then we're going to continue moving it by scroll X another 20 times, but for that last 20 times we're going to be fading away. So we're going to change our ghost effect by 5, and eventually it'll get to 100, so it'll be invisible, and once it's invisible we can delete that clone. So yeah, that has to be inside the if statement. Hold it. So all of this stuff, sorry, I placed this the wrong way. Everything that we've just programmed here has to be inside this if touching edge. So let's just reposition these guys. We're going to put this right inside here. Perfect. Okay, so we should be able to drop our presents now and have a look at what that looks like. So we're going to drop it and splat it on the ground, and there you go. And then it fades away after a while. Let's do that again. There we go. And you can see how they're kind of behind the buildings. So you're not always, well, it will never be completely behind the building, of course, because if it touches a building, then we will have successfully hit it, and it'll be a different circumstance. Okay, so now we need another if statement to deal with what if we do hit the house. So I'm going to do a second if statement here underneath the first one. So everything else that we just did below the change velocity. Everything else is inside this touching edge. Now we have another if statement here. If touching buildings. We're going to do a couple of things here. The first thing we're going to do is start a sound. I have 10 different fun sound effects that we can play if we successfully get a present on a house, and there's just some cute stuff. Some of it's recordings of kids, some of it's fun stuff that I did on my own. I can play you some samples here. Let's try another one. Oh, he's going back to the same one again. Let's try one more.
Thank you, Santa Claus.
There you go. So we've got all sorts of fun little sound effects playing here. I'll leave you to explore the rest of them on your own. So we're going to play a random sound effect here. So as soon as the gift lands on the house, we have to find a way to figure out which house it landed on. That's a little bit complicated because this is a clone touching a clone, and the clone that's touching won't know which clone it touched. A little bit complicated. So the way we can figure it out, though, is by by storing the location where it touched and then going and looking to see which building is also at that location. And that's a sort of little hacky way to get the house to recognize it's been touched by a present. You cannot have two objects sensing in each other. We can't have an if statement saying if the house is touching the present and the present is touching the house. One of them is always going to activate itself first, which is going to deactivate the other one, because we're going to end up deleting one of the clones or doing something else that's going to mess our code up. So it's always a little tricky when you're dealing with clones intersecting with clones, and there's different strategies depending on the kind of game that you're making, but this one works quite well for this game. So we've got a variable here called gift landing x, and we're gonna store that we're going to store our X position in there. We're going to store our Y position in gift landing Y. And those are global variables because there's only going to be happening once at a time on the screen. And we need the buildings to be able to read it all the time. So we're going to use a global variable there. Let's put that right underneath there. All right, so that's going inside the if statement again. All of this stuff is going inside the gift statement here. Inside the if statement, sorry. Okay, so we're storing that position that where we're landing. We're also going to make a graphic fly up through the air here that's telling us whether we have a streak score. So basically we're going to create a clone of this graphic over here. Let me show that to you, which is showing us what kind of streak we have here. So we start at 1 and then go up to 2. It's a little hard to see the yellow here. Let me make that visible on the screen. We're going to be shrinking these quite a bit. But so the first time when we score points, we're going to get an ordinary +1. But just to remind us that we're on a streak, this graphic will go up every time we change our streak score, basically, all the way up until we get to a streak score of 10, which is the max. In addition to getting 10 points, we're also going to buy bonus time for the game. If we can keep a streak score going for long enough, we can extend the length of the game. The game's only supposed to last 60 seconds, but if you're really good, you can have a chance to really blow your score through the roof here by adding time to your game. So that's another little twist that I added to the game. All right, so we're creating that streak score, and that's going to just float up into the air and disappear. We'll deal with that a little bit later. We're going to broadcast a message here called gift delivered, and that is going to have an effect on the buildings. It's going to make the building start to glow a little bit, and it will also change a variable inside the building so that the building knows that it has successfully had a present dropped on it. Because if this building manages to get to the end of the screen with no present being dropped on it, we're going to have some unhappy children. So that's what we're going to have to deal with here. We're going to delete this clone, but we need time for the buildings to receive the message that a gift has been delivered. If we delete the clone right away, when it's the building's turn to process its commands, it's not going to be able to have all the information that it needs to process that. So that's why sometimes we need to add this wait 0 seconds in here before we delete a clone, just to give anything that's reliant on it a chance to process its commands before we go ahead and delete the clone. All right, so we're going to wait 0 seconds and delete this clone, and that is looking good. All right, so we're not 100% done. There's a few things that aren't quite plugged in yet, like the streak score and some pieces of the building, but we can do a preliminary test on this mechanism here. So we can drop a present on a building, and we should at least get a happy child. There we go. Beautiful. So we got a random sound effects playing. And you can see that our falling mist sound is working nicely here. Okay, so everything's working quite well here. So let's go over to the buildings now. You'll remember that we broadcast a message here called gift delivered. That is going to get sent over to the house, and the house is going to need to register that it got touched by a present. So let's go over to the buildings now. And so when that gift delivered message is received by the buildings, now every single clone is going to get this gift delivered message. So we don't want them all to actually register that a gift has been delivered. So here's where we're going to check and see if we're touching Santa. Now, we're not allowed to actually touch Santa because we're not low enough on the screen to touch him. So the only part of Santa that's going to touch the building is going to be one of the falling gifts. So we'll know if we're touching Santa that the gift will have been delivered to that specific building. I mentioned the XY coordinates that were being saved before. I was wrong about that. Those saved XY coordinates are going to be for the streak score, so that it knows to appear on top of the spot where the present dropped. So I misinformed you back there. So if I'm touching Santa, we're going to change a variable here called delivery complete to 1. This is a local variable. Each house will remember whether it's had a present delivered to it or not. So if this number is 1 when we leave the screen, then all will be good. But if the building leaves the screen and that number is still 0, then we're going to have some unhappy children, as I said. All right, so we've got that gift delivered, that delivery complete is done. And after that, we also want the house to give us a little bit of a visual cue to let us know that we did, in fact, hit it. It's pretty obvious from the sounds and everything, but we're just going to make the house get a little bit brighter and a little bit darker. Let me show you what that looks like. Let's just get a building on the screen here. We're just going to tell it to change its brightness effect by 50%, so 10 times 5. And then back down to normal again. And so when I click this on a house, you can see it kind of appears to glow there. And there will be just one more visual cue to let us know that we successfully touched the house with a gift. We want to make things nice and easy for people who are playing the game. I think lots of beginner game developers don't pay enough attention to these subtle little details. You don't want players to have to figure out what's happening. You want to kind of hammer them over the head with what's happened here. And so making the house glow will make it extra obvious that we hit that house with a present. Let's have a look at what that effect looks like in the actual game here. We'll drop a gift.
Heat wheel! Santa's wheel!
There we go, perfect. And let's do another one.
Thank you, Santa Claus!
There we go, perfect. And that is Mr. Tomec's voice acting. You can feel free to let the Academy Award Nominations Committee know about what I've been working on here. I think I did a fantastic job. All right, so we've got our gift delivered here. That has flipped this variable over to 1. And now we're going to go back to the spot where the house is fading away here, and it's reached the end of the screen, and we're going to add an if statement here to check if that delivery complete is in fact 1 or not. So we've got an if statement here. I'm going to move it. Let's fill it up in a second here. So I'm going to move this if delivery complete is equal to 0 right to the spot in the script here where So we're back inside the when I started the clone script here. And so here's the spot. Repeat until we get to negative 230 on the screen. And while we're doing that, we're scrolling across the screen. So this is the spot where we've reached the end of the screen and we're about to start fading away. So right in here, we're going to check and see if we finished our delivery or not. Let's just give it some breathing room here. All right. So if delivery complete is equal to 0, which means we missed a house, then we are going to, the first thing we're going to do is move 40 steps. And we got a little graphic that's going to appear here, and it's actually part of the buildings. So our building is, as it's, instead of fading away, it's going to turn into this graphic here, sad kids. We can see our kids crying and saying they missed us and we lost 2 points. So again, a nice little visual symbol here to let us know what happened. Hitting our players over the head with a hammer to make sure they understand what's going on, right? So why are we moving this graphic 40 steps here? Well, when it gets to the edge of the screen here, let me just make this visible here. When it gets to minus 230, it's going to appear on the screen like that, which is no good. So we're going to bump it over 40 steps so that when it appears on the screen, it's going to be here and nice and visible. So yeah, it wouldn't do a lot of good if it was half off the screen. But we don't want it change where the houses disappear, so that's why we're just having this graphic jump a little bit over to the right. It's going to the right, of course, because everything by default is pointing in direction 90, which is to the right. So moving 40 steps, we'll just move it right into the area of the screen we can see here. All right, if we messed up, we're going to lose our streak score again. So we're going to set our streak score to 0. We're going to switch our costume to that sad kids costume that I just showed you. And we have a little sound effect to go with that. Very sad for everyone. Then we're going to wait a half a second, and then we're just going to fade out again. So it doesn't matter whether we're a building or whether we're this graphic, we're still going to fade out and delete the clone again. All right, so that is working quite nicely now. Let's give that a little try. So I'm going to successfully deliver a present to the first house. Okay, so I'm going to successfully drop a present on the first house here.
Thank you, Santa Claus.
And you can see that it'll disappear without event. But the second house I've missed here, and you're going to see that there's going to be some dire consequences. There we go, and we get the missed house. And this is another missed house. I'm going to catch this one, though. And you can see that one passed away fine. This one's fine. This one's fine. And we're going to miss this one again. And there we go. That turns into a crying child. Perfect. Okay. Things are going swimmingly. Okay, so now that we're successfully hitting buildings, we'll want to keep track of how our score is improving. Remember, we have a streak scoring system here that's going to reward us for consecutively doing the right thing and punish us for making mistakes. So we want some visual feedback again to make sure that that's really obvious to the player, whether we did well or did poorly. So that's where we're going to use this streak score graphic. So we're inside the streak score sprite right now. And you'll remember there are 10 different graphics here, one for every level of streak. It's a little hard to see on the screen here because it's yellow. So let's go ahead and code that. When the green flag's clicked, we're going to hide it. And the clone of this is actually being made over in Santa. So we don't have to create a clone here way over in Santa when this is the present. Remember that we created a clone of streak score right here. And this is where this gift landing X and gift landing Y is also going to come into play. We're going to want that streak score to come up from the spot where the gift disappeared from the screen. So that's why we're storing that location here right now. All right, back to the streak score. When I started the clone, we're going to go to that gift landing X, gift landing Y, those XY coordinates, and that will put our floating streak score in the right spot. It's invisible under the master here, so the clone's going to want to be visible. I've designed this way too big again, so we're going to shrink it down to 30% in size and make sure it's at the front. We don't want it behind the buildings. And so we're going to check here first of all to see if the streak score is less than 10. We don't want to get a streak score of 11 or 12 or whatever, so we're only going to, so every time we create a clone of the streak score, we're going to change the streak score by 1 so that the next time it's a bigger number unless something bad happens along the way. But we don't want to let that number get above 10, so that's why we're putting it in an if statement here. So as long as we're less than 10, we're going to change it by 1, which will bring it up to 10 and no higher than that. Okay, beautiful. Now we have another if statement here. We're going to say if streak score is equal to 10. So we got a special little bonus here that says if the streak score is equal to 10, we're going to change the time remaining by 2. So if you can get 10 in a row, you're going to start making incredible points, 10 points per drop. But you're also going to add to the time limit of the game. So that's going to let you score mega points if you can get to that point. So if you can, so really good players of this game are going to be rewarded with very high scores, and mediocre players are going to be quite low, perhaps even in the negatives, because you're going to get punished every time you miss something. So I'll be interested to see what the high scores look like after we get that going. All right. So we're going to change the score at this point now by the amount of our streak score. So it's going to be a variable amount that depends on how many of these we've successfully got. Now here's where we're going to get the streak graphic onto the screen. We're going to switch the costume to the streak score. So if our score is 5, we're going to switch to costume 5, which says +5, etc. like that. So we're going to switch costume to the proper one. We're going to make sure we're pointed to the right. We're going to start wobbling around in a second, so we want to make sure that the graphic is straightened out before we start doing that. Now we've got a temp variable here. Now this gets into some complicated math here. We've covered this in a couple of other tutorials. We're going to use the sine function, which is a mathematical function that has to do with trigonometry, and I've done separate tutorials on this before. I don't want to belabor it and get you guys all clouded up with math during your Christmas break right now as well. So all you have to know right now is that the sine, when we take a number like a temp variable and we run it through this sine, it always returns a number between -1 and +1. And it kind of, that number goes up fast, and then slows down when it gets to the top, and then starts to go into the negatives slowly at first, and then more quickly. And so this sign is really, really useful for creating swaying motions or pendulum motions, or motions where things get bigger and smaller in kind of a pulsating kind of way. Super useful function for all kinds of Scratch projects. So we're going to have the thing wiggle around a little bit as it's rising up the screen here. So I'm going to put this inside a repeat 25 loop, and we're going to turn the sign of this temp variable. So we're going to start changing this temp variable, and that's going to make it wobble left and right. So as that number gets bigger, it's going to go back and forth between -1 and +1 and +1 and -1. But we're going to multiply it by some stuff, and we're going to make this temp variable bigger. Again, we don't have time to get into all the math here, but what's going to end up happening as a result of this is it's going to start wobbling. Let's just try the simple version of this, sine of temp. So we're going to turn the sign of our temp variable, and then we're going to change our temp variable. I just want to show you quickly what that looks like. So we're going to keep changing that temp variable every time that we go around this loop. Let me just run this loop here for you so you can see what that looks like. So it's wobbling just a little bit. It's quite hard to see here, but just a little bit of a wobble that goes back and forth. We want that wobble to be more pronounced, so that's why we're going to take this sine number and multiply it by 4, so that instead of going between -1 degree and +1 degree, we're going to go back and forth between -4 degrees and +4 degrees. So let's look at what that looks like. So you see it's much more of an obvious wiggle. We've got to reset that point in direction to 90 to make it work properly. There we go. So now we're wiggling quite nicely. Now we're going to so that's basically what our wiggle is going to look like, but we're going to make this thing go up the screen while that's happening. So we're going to change our Y by 2 while we're wiggling. So let's see what that looks like now. You see it's floating up the screen. There we go. And, but we're also going to want it to continue moving along with the screen. We want it to stay floating above the house rather than have the house float away. So we're going to use that change X by scroll X here again to make this thing move to the left to match the speed of the scrolling of the house. We're going to make it shrink a little bit as well, and eventually we're going to make it fade away as well. So let me show you what this is going to look like. So we're going to shrink as we go up. Just a little bit. So that's the first part of it. We've cut this into a couple of different parts because now once we're done floating up a little bit, we're going to start fading away. So we're going to do another loop here where the same stuff is happening, but we're also going to be fading away. So we're doing this 50 times, and we're going to change our ghost effect by 2. So at the end of this loop, it should be totally invisible. The rest of this stuff is pretty much the same. It's going to turn by the same sine formula as before, change its Y. We're going to change that temp variable. So everything else is going to function exactly the same here, and the size is going to continue to shrink, but it's going to eventually disappear. And after it's done disappearing, we're going to delete the clone. So let me show you what that looks like now. Well, let's simulate that one more time here. We'll just start at the beginning of this loop here. There, you see. And so it kind of appears to be floating off into outer space. Okay, we can try this with the game and see if the thing's moving along with the screen and whether it's looking appropriate here. So let's give this a try. So let's drop a present here. And there's our first streak score. Let's do another one. And our streak is at 2 now. Beautiful. Let's try it again. Oh, I love it. There we go. And things are going quite nicely here. Okay, that's working beautifully. Okay, so our game's going to get progressively harder the more that we play it as the screen starts to scroll by faster and faster and faster. But we want to add some additional difficulty to the game, especially we want something to stop you from camping at the front of the screen here, where you can have the maximum amount of time to drop stuff successfully onto a house before it gets too far down the screen here. So that's gonna, we wanted to create some kind of a mechanism here that would force you to go backwards and retreat every once in a while to where you have less of a chance to hit these houses and more a chance of them escaping you. So what's going to happen is every once in a while, airplane, helicopter, or flock of geese is going to fly across the screen here at a random height. And if you're not careful, you're going to end up bashing into it, which is going to freeze you for a couple of seconds. And it's also going to ruin your streak score as well. So let's go ahead and code that. Now, we wanted to give you some warning. I initially, so I've got a little warning sign up here that's going to appear on the screen just to freak you out a little bit and get you to back up when you think that an airplane or bad thing is coming. So it's kind of like a radar here. It's going to let you know that that something is coming somewhere on the screen here. We initially had it set up so that the warning sign came at the altitude where the thing was going to drop, but then there was really no incentive for you to back up on the screen. You just had to move up or move down to avoid where the thing was coming, and I actually wanted you to force you to retreat on the screen. And so that's why we decided to have the air traffic warning pop up right up here in the middle of the screen. It's going to flash a couple of times to let you know that something's been detected by your radar up ahead, but not how high or low it is. So we're going to start with that. We're going to get that warning signal up, and that's going to create the clone of the actual aircraft that's going to end up possibly bumping into you. So we're going to start with a green flag. We're going to hide the master, and he's going to make clones of himself again, as we often do. We got a forever going here, and we're just going to be waiting a random amount of time for the next airplane to come. So right now I've got it set for 1 to 8 seconds. Again, this is an area where you can customize it however you want, depending on how long you have to wait for the next airplane to arrive. 1 to 8 worked quite nicely in our play testing though, so I'm quite happy with that. We're going to clear graphic effects. When our plane crashes into Santa, it's going to do some graphical things to make it clear that we've been hit, and we want to make sure it doesn't remember that from the last time, so that we come up with a nice clean graphic without any graphic effects on it. All right, we're going to go to the middle of the screen, which is an X of 0 and a Y of 150, which should put it right about here. We're going to want to make sure it's pointed to the right, and we're going to switch costume to this caution sign, that yellow exclamation mark symbol. And we're going to play this ping sound. We're going to do it 3 times. Like that, basically. And our thing's going to flash and make that sound. So we're going to make the ping sound and then show and then hide. We're going to have it flash and ping, basically. Let me show you what that looks like. Well, actually, I think the ping was just going to happen once. You can make it go either way if you want, I guess. I think I'm trying to remember which way I had it in the final game. I think leaving it once is probably a sufficient warning, but again, you can customize that however you want. So we're going to play that ping sound and then flash a couple of times, and then at the end of all of this, we are going to switch costume to one of the 3 bad guys who can end up hitting here: the airplane, the helicopter, or the flock of geese. So we're going to pick costume 1, 2, or 3, and that's going to decide what we hit here. And then after we've switched costume, we're going to create a clone of ourselves. So this guy's hidden right now. When we switch costume here, he won't actually, you won't actually see it on the screen until the clone appears on the screen. All right, so when I started the clone, let's go through what happens there. So first of all, we want our guy to appear at a random height on the screen. We're picking an X of 210, which would get him started right here on the right side of the screen. And we're going to pick a random height, somewhere between a 150 high and minus 50 low. So that should be enough so that pretty much no matter where you are on the screen here, Santa is not safe anywhere. We're going to make sure he's pointed to the right now. Okay, we're going to set our volume to 100% because we do change that later on, and we want to make sure that that's reset to full volume. And now we've got a couple of different if statements here that are going to make a different sound come up depending on what is coming across the screen. So if our guy is wearing the first costume, the helicopter costume, it will play this sound. There's their helicopter. Now notice that if I'm not wearing the helicopter sound or the helicopter costume, that's not going to work. Right? This block will only work if we're wearing the appropriate costume, and so it's playing the sound depending on what it looks like, which kind of makes sense. So if costume number is 1, we're going to play a helicopter sound. If it's 2, we're going to play the airliner sound, which is this one. And if the costume is number 3, the geese, we're going to play this. There we go. Now we're going to want these guys to be visible and quite a bit smaller. We're setting their size to 20%. And we're going to basically have them scroll their way across the screen here. So they're going to move at a speed of 5. So we're going to change their X by scroll X minus 5, which is going to get them moving leftwards across the screen at a speed of 5. until they get to the end of the screen, which is an X position of minus 240. They're going to keep doing that, and then they're going to hide. And then we're going to change the volume by minus 5. I'm not sure why we didn't delete that clone there instead of hiding this guy. That is a little bit weird. You know what? I think we should actually delete the clone instead. I'm not quite sure why I did that. So we're going to change... Oh, I see. So we were hiding because we're changing the volume here, and that's going to take a bit of time to happen while the sound is fading away. So we're going to hide and just stay hidden at the edge of the screen here until the volume goes down to 0 to make it sound like it's going off in the distance. And I don't think we're deleting our clone anywhere else, so let's go ahead and delete the clone right now. Beautiful. Okay, I got a little bit of other code here that's already built here. And let me just explain how this is going to work. So this is just in case there's geese coming. So the rest of the air traffic doesn't have any costumes, but the goose does have a costume. He's going to be flapping his little wings around. Let me shrink this a bit so you can see. So we're going back and forth between these two graphics here. So we don't have to do that for the other two characters, but for this one we do have to get some flapping going. So we're going to say if we're wearing costume 3, we're going to forever switch between costume 2 and costume 1, basically. We're just going to get into the endless loop until the delete this clone happens, in which case it'll all stop. Okay, so we can't interact with anything that's flying in the air right now, but at least they're being spawned. So let's just give it a quick try here and make sure that these guys are being spawned the way we expect them to. Let me just start dropping presents here.
His wheel! Santa's wheel!
And we'll wait for our first warning. There it comes. And it's a helicopter. Let's see what else comes here.
A PlayStation! Yay!
Here comes our next air traffic here, and it's an airplane. There we go.
Merry Christmas!
And here comes somebody else. So now there's jet plane. Here comes somebody else. We're not. There's a goose. There we go. And they're animating properly. Beautiful. Okay, that's working quite nicely now. Okay, next we have to deal with the collisions so that Santa can actually crash into these guys. Now that happens in 2 different places. We're going to have Santa do the actual detecting, and then he's going to broadcast a message to the airplane to make, or to the air traffic to make it crash properly. Okay, let's go back to Santa for a second here. So we're starting a new green flag here. And we're going to start checking forever to see if we're touching air traffic. So if we are touching it, we're going to set this frozen variable to 1. Remember, the frozen variable is what's going to stop us from moving after we've crashed. We don't want to actually kill Santa Claus here, so we're just going to make it so that he can't act. He'll be stunned for a few seconds, and that's going to mean that we're probably going to miss out on some dropping some presents. Okay, we're going to change the score by -5 if we hit some air traffic here. And we're going to make Santa turn dark. So we're just going to use this set brightness effect to 50%. You can see it turns Santa into kind of a silhouette here. And that will be the visual indication that we need here to know that, that he's been hit. We've got a little explosion sound we can play here. And so that's going to play every time we hit something. We're going to broadcast this crash message, and that's what's going to be received by the air traffic to make it disappear, and other stuff's going to happen. Then we're going to wait 2 seconds. We're going to clear the graphic effect so that dark effect disappears. And so during that 2 seconds, our frozen is going to be set to 1, and again, we're not going to be able to do anything. But then we're going to set it back to 0 again, and we're going to resume our normal control over the game again. All right, that should be working, but we only have a little bit of code to do to code the air traffic end of this crash too, so let's go ahead and do that before we test this. We'll go back to our air traffic again, and we're going to look at the crash, when I receive crash command here. All right, so when I receive crash, if costume number equals 1 or 2, we're going to play, so we're going to do something a little different depending on whether we hit geese or if we hit airplanes, because obviously it's a different kind of effect we're going to need here. So the first thing that's going to happen if we hit some air traffic is we're going to get a mayday sound.
Mayday, mayday.
There we go. And then we're going to shake our craft around a little bit. So this is the only thing that's going to be inside the if statement here. The rest of this is going to be outside the if statement. We're going to do the same thing to all these guys regardless of what happens to them. So we're doing a bit of a shaking effect here. So we're repeating 20 times. Let me show the graphic here and I'll show you what that looks like. Let's get an airplane that's a little bit easier to see in the air here. So what are we doing? We're changing our X by somewhere between -2 and 2. Then we're changing our Y the same way. And we're turning a random amount. And as that's happening, we're changing our ghost effect by 5 each time. So at the end of this loop, our guy should be completely disappeared and he'll kind of have shaken up. So this is how we're going to simulate the kind of explosion that we're looking for here. Let's see what that looks like. There we go. Beautiful. So when we pair that with the mayday sound and the explosion, it's going to look like these guys have gotten into a crash a little bit. Then at the end of that, we're going to delete the clone. Okay, so we've got a bunch of different overlapping sound effects. They don't all play every time. There's some quirks and scratch that stop it, but mostly this is going to work. Okay, so let's go airplane hunting here and see what we can hit. So there we go. Here comes something. I'm going to actually aim for it. There we go. Crash. And for that couple of seconds, oh, now we're getting geese like crazy. And again, I can't move. There we go.
Mayday, mayday.
There we go. Beautiful. Let's hit an airplane.
Mayday, mayday.
Love it. Okay. So our hitting of the aircraft is working quite nicely now, and that is going to mean that you have to be super careful when that warning message comes up, or we're going to end up hitting something. Okay, just one little bit of code. I think we're actually all done with the air traffic except for this little bit of code. We're not going to need it till later, but we might as well code it while we're here. It's called when I receive game over. We're going to stop other scripts in the sprite. And that's going to stop new airplanes from being generated after the game is already over, basically. The stop other scripts in this sprite, in case you're having trouble finding it, it's actually under control, and you'll find a block that's called stop all, and it actually changes shape when you pick something else. You can pick this script or other scripts in this sprite. So that's what we're going to do here, is just stop everything else inside the air traffic here from working after the game is over. All right, to set the right mood for this game and also to make it just a little bit harder, we're going to add some clouds up in the sky. They're going to be transparent, and Santa's going to end up kind of flying behind them from time to time, just to add a little bit of confusion to the mix here. So I've created a cloud sprite, which we're in right now, cloud, and it has a bunch of different costumes just to randomize the look of these clouds. There we go. So we're again going to be using clone, so we're just going to hide this guy, and we're going to set his ghost effect to 20. So these clouds are going to be quite transparent. So here's what the default cloud looks like, and we're going to give it more of a nighttime look by giving it some transparency here, and that will, you can see how Santa is still visible but a little bit obscured behind that when it's at 20% ghost. We're going to set its X to 300, which is basically right off the screen. And we're going to have it sitting there making clones of itself. So we're just going to forever create clones of ourselves and wait 5 to 10 seconds and make another clone. And we're just going to have the clones drift casually across the screen until they disappear on the other side. So when these clouds start as a clone, we're going to want them to switch to one of these 4 costumes randomly. We're going to switch costume to pick random 1 to 4. We're going to bring them to the front so they're covering up Santa, possibly. We're going to want them to go to a random altitude on the screen here. So we're going to set their Y to somewhere between -50, which is right above the rooftops here, all the way to the top of the screen, which is a +180. They've been invisible till now, so we're going to make the clones visible with a show command. Now we have a local variable here for cloud speed. So each cloud is going to be moving at a slightly different speed just to make it look more realistic. So we're going to set cloud speed to a random speed from -0.5 to -2. So they're going to be moving quite slowly across the screen here, but at varying speeds, and that's going to make them kind of overlap each other in a nice little way. Okay, and we're just going to keep changing their X position until it reaches -250, which will take it off the edge of the screen, and we're going to move at that speed in steps. So whatever speed we picked here is the speed that's going to move across the screen here. Beautiful. It's going to keep doing that till it hits -250, and then it's going to delete off the screen here. All right, I think that's it for this code here. We do have a little bit, again, another game over command here, which is when I receive game over, we're going to delete all the clones, and we're just going to stop the clone creation process with a stop other scripts in the sprite again. And that's it for programming the clouds. Let's just have a look at what they look like. And there's our first cloud. You can see it just adds a little bit of realism to the screen here. Again, kind of hide behind them a little bit. Whoop. Neglecting my Santa duties. You can see this cloud moving quite a bit faster here. Whoa, I should have deked away from that one. All right, good. So that's, again, a nice little visual touch. Doesn't really change the play mechanic much, but those little details, if you sweat them, that's how you're going to get a really good game. Too many kids that I see making these kind of games, they're just trying to get it done and move on to the next thing. And I spent a lot of time working on details of this game, thinking, how can I make this cooler? How can I make it nicer? And these clouds are another little facet of that. Okay, we are almost done this game now. Now we need to set up a timer, and we need to set up a game over screen and a couple of other things like that. We're going to do that all inside of the backdrop and the thumbnail. So those are the last little bits, and then we're going to be done. Let's go over to the backdrop for starters. So there's only one costume in the backdrop, and that is this starry background. So there's not much going on here, but as is a tradition in these kinds of games, we're going to have the background music and some of the other controls happening inside the backdrop. We've already put our scroll X command in here, and we got a few more things to do inside the backdrop here. Firstly, we're going to set up our timer here. So when the green flag is clicked, actually, and we're also going to do a broadcast here, start music. So we've got a little musical soundtrack here. It's a little bit of music that I grabbed from my friends over at WeVideo. They've got a massive sound library there. And I picked a really lovely little Christmassy track. So I've broadcast this instead of having the music play here, because there are going to be other times when I want to restart the music. Over when the game is over, we're going to want to restart the music from the beginning again. So instead of coding it in two different places, I'm just doing a broadcast here that is going to start it off in both places. So when I receive that message, we're just going to start playing this music forever from the beginning. So each time I get this broadcast, it's going to restart the music. Let's have a quick listen to the music. And you can see how when we rebroadcast it, it'll restart the music again. And so that will help us restart the music when our game is over again, while we're looking at the thumbnail again. All right. So let's get on to our timer now. When the green flag is clicked, we've got a variable here called time remaining. And that is up here on the top left of the screen. We're going to set a 1 minute timer here. And we're just going to keep decrementing it down. So we're going to go, we're going to change that variable by -1 each time we go around that loop until the time remaining is less than 1, which will mean it'll be 0. I guess we could go equal to 0 here, but I like doing it this way. Also, we're going to be adding to the time, so we just want to make sure that that we don't get into any circumstances where we end up in a negative number. I just think it's safe usually to go with -1 here instead of equal to 0. So we're just going to make it go down by 1, wait 1 second, down by 1, wait by 1 second, and when that finally runs out, when we get down to 0, we're going to broadcast a game over message. All right, and there's a little bit of code here for the high score. We'll deal with that in a second here. So when we get the game over message, we're going to jump over to the thumbnail. And when that message is received, we're going to switch our costume. So we've got a couple of costumes here in the thumbnail. Here's our basic thumbnail. And here's our game over thumbnail that has some graphics in it for showing what our high score is going to be. So what our final score is going to be and our high score. You can see I've got a little cloud here. So this is going to be a cloud variable, and you're going to be able to check your score against the highest score in the world and see if you can get a global high score at this game here. And I'm going to show you how to do that in just a second. So the game over screen isn't too different. It's just a variation on the thumbnail here. So I've done thumbnails for other games as well, and it's going to be kind of the same routine here. So when I receive game over, we're going to switch costume to game over, and then we're going to change ghost effect. So we're going to have our thumbnail ghosted, and when the game is over, it's going to unghost itself. So it's going to go back down to 0 again, and we're going to be able to see this game over screen. Let's have a look at the master thumbnails screen. Now, we've done thumbnails for most of our games lately. Just a nice way to start off your game so that when people first land on it, they see something a little more professional rather than just jumping right into the game. And what we do with these always is we make them appear at the front of the screen, and then we have them basically ghost themselves so that as soon as we hit the stop button, it'll reappear again. Let me show you the code for that one more time. We're going to go right to the middle. We're going to go to the front. We're going to switch our costume to thumbnail in case we're in that game over screen. And when we click green flag, we're going to have that thumbnail disappear. It's going to ghost down to 0 again. But we're going to keep it at the front, so we're going to get into a forever loop here where we're just constantly going at the front. And let me show you what that looks like. So as soon as I stop the game, I'm going to see Santa Claus Lane here at the title of the game. And as soon as I start playing, it'll fade away until the end of the game. Okay, one last little detail to attend to, and that is the high score. So let's go back to the backdrop again, where I've got that code all ready to go here. So when I receive game over, when that timer runs out, we're going to stop other scripts in the sprite. That's going to stop the timer and stop the music. But we're going to restart it again right away. So as this game over screen starts to appear, we're going to start the music from the beginning again, which I think is kind of classy. It's just like hitting the reset button on a game. We're going to set the final score. So I've got two different versions of the score. I've got the score up top here, but at the end, when we switch to the other thumbnail here, which I'm going to show right now, I want the score to appear right in this spot here. So what I'm going to do, what I did was I'm going to transfer that existing score to a new variable called final score. And the reason I did that is so I can move it to a different spot. So that final score is going to appear right here on the screen, just like that. And the high score, the global high score, is going to appear right next to it right there as well. And that's a cloud variable. So if you're not a scratcher yet, you're not going to be able to use high score. And what I would suggest is until you get the ability to use those cloud variables, you should just delete this box off of it and don't mention anything about high score if you're going to be doing a remix of this game. Keep it up. Just write some comments on the comment board, share some games, play other people's games and comment on them. And if you play nicely for a couple of weeks, you will get that scratcher status that will give you access to cloud variables. Okay, so we're going to hide these variables, time remaining and score. And but before we hide the score, I had some problems in the play testing of this. We have to just set all these other scores before we hide the variable. It appears that when we hide the variable first, these scores don't get updated properly for some reason. So if score is greater than high score, so if our score is better than the global high score, then our score becomes the global high score. Set high score to score. So that's what's happening. We're just comparing our score to that global value, and we're updating this number if necessary. All right, then we're going to hide that variable up top, the score. We're going to show that variable final score, and we're going to show the variable high score. And that looks like it. Let's give the game one last run through here and see how we do. I'm going to see whether I can get myself a nice score here. So, whoop, I missed with my first shot. Unbelievable. Okay, here we go. Let's get a streak going here. Duck, dive. All right, these little houses are really hard. So remember, you can get more than one present on a house. That's totally legit.
He's wheel, Santa's wheel.
Beautiful.
He's wheel.
All right.
Santa's wheel.
So we're up to 10 points now. Now we're adding time to our game. That means, oh, and I've crashed there, and I'm going to miss that house because of that. Oh, and I've lost my streak. I'm just freaking out now. Whoop. There we go. Whoa, and now I've hit a helicopter. I was doing so well, and then things started to fall apart here. All right, I got myself some extra time during that streak, though. And that's going to serve me in good stead. If I can get up another streak going here, I might be able to keep the game going for a little while longer. Here we go. Nice. Oh, and I missed. I lost my streak again. So as you can see, we can keep this game going for quite a while here if you can keep those streaks up and running. Here we go. Things are going very quickly now. All right, we're adding to our time again. Oh, I was just about at the end. Whoop, and let's just end it here. All right, anyway, things are working quite nicely here. Whoa, and there we go. So my final score, 260. Thanks in part to some of the bonus time that I got here. So despite the fact that this game has a 60-second time limit, you can actually end up playing for quite a while if you get good at it, though eventually things are going to get kind of scary as the houses start going by faster and faster. You're going to end up missing some Santas, and you're going to break your streak. So I'd like to see how fast you guys can get at it. Please mark down your score in the comments underneath if you play this game, and love to see you remix this. What can you do to make this game more fun and exciting? So I hope you have fun playing this game, and I hope you try making it yourself and maybe change some of the rules around, change the graphics around, and show me what you can do with this basic code here. I think I made a fun game here. I'm quite proud of it, and I had a ton of fun making it, especially making those funny sound effects. So please drop me a like and a comment and maybe even a subscription if you haven't subscribed yet. And I'm looking forward to making even more fun projects in the new year. In the meantime, a very Merry Christmas to you and all your families from the family here at Chromeworks. Thank you very much for another great year working with you. I will be back in the new year. Bye now.